1.3, finding limits from a table. This lesson on Delta Math is not super tricky, but it's going to look like this other than you're going to have to put values in the table yourself, X values, and then they'll come up with the Y values. I went ahead and just snipped some of them so you could see it, but just realize Delta Math, you're going to have to be doing these tables yourself. So here's what's happening is we don't have an actual function. We have no equation, no function we could graph and look at it. They're only giving us a table and we're allowed to put in X values and see what's happening as we're approaching some number. So number 1, and I will say that each row they go together in the same problem. But on number 1, we're trying to find what's the limit as x approaches 2 from the left of our unknown function. So I would start out by saying, okay, well, what's a number slightly smaller than 2? Not even 1, we want to get even closer. Like we're wanting to get super close. So start a tenth off and say 1.9. Well, 1.9 would be like right here. When I have a value of 1.9, my Y value is 2.8. So let's just say it's like right there. When I plug in 1.99, so now I'm getting even a little closer to 2, I'm getting 2.98. It's like such a small difference. As I'm getting even closer to 2 with 1.999, I'm getting 2.998. Getting even closer. 1.999, 2.9998. So you see the trend. I'm getting closer and closer to 2, and then what Y value am I getting super duper close to? Looks like I'm getting close to 3. So it doesn't matter what this side is doing. This side could do whatever it wants, right? But we know that as we're approaching 2 from the left, we're approaching 3. Okay, and then now we're doing 2 from the right. So think about a number slightly bigger than 2. Let's go a tenth more, which would be 2.1. Put us right here. When I'm at 2.1, I'm at a value of 4.4. So let's say there. Then I'm going to get even closer. So I'm going in towards 2. 2.01 will be 4.04. So I'm getting a little smaller and smaller and smaller. Smaller and smaller. So at 2.00001, which is almost at 2, I am basically at a Y value of 4. So again, it doesn't matter what the rest of it's doing. We only care about right here. Okay. So then the general limit. Ooh, my sweaty hand just smeared that ink. The general limit, can we say a general limit exists if when we're coming from the left we're at 3 and from the right we're at 4? No, they have to equal the same value. There's a jump here. And then f of 2, you would simply plug in x is 2 and it'll bring it up, so 4. So what's really happening is there's a close point here, but this would be an open circle. And that would be our piecewise function. Okay, so hopefully that gives you some kind of visualization. All right, the next one is dealing with our x value is -5. We're going to go from the left, the right, see if the general limit exists, and then is there a function value there. Negatives are a little harder for my brain to wrap my head around. I'm not super good with thinking of the values, but when I'm coming from -5 from the left, I want to think I'm going closer towards -6, right? So -5.1 would be the next value, and I get out -1.61. And then I plug in -5.01. And I just keep adding zeros and moving the 1 over, so I'm really getting very minusculely close to -5. And then look, -1.9999999, that is approaching -2. There's an obvious pattern there. All right, number 6, I'm approaching -5 from the right. So think you're wanting to get closer to 0. So you're on the other side of -4.9, and then you're just going to keep adding 9s and see what's happening. So we're -0.275. And look what's happening. We're -0.25 and then a bunch of zeros. Well, that's just -0.25 or -1/4. Are those values the same? No. So our general limit does not exist. And then when we plug in -5, we get undefined. So obviously it's undefined. Okay, I'm going to let you try 9 through 12. 9, 10, 11, 12, and I really like these. So as we're approaching -2 from the left, we're getting closer and closer where it looks like we're getting close to 1. And then on number 10, when we're coming from the right, we're getting close to 1. So because these match, we're at 1. But look what happens when I plug in -2 to my table. It gets me that there's an undefined value there. This is just a guess of what it looks like is at -2, then that means there's a hole. But my limit exists because I'm coming to that same value of 1 from the right and the left. So it's kind of neat how it all plays together. I will say this though, a lot of people say, well, how come I can't just jump from like -2 to this? Well, you want to see the pattern, because what happens sometimes is there's not an actual pattern. Sometimes things oscillate, which is they go back and forth really fast. Trig functions do this. And then that means a limit wouldn't exist either. So you have to really try one value and keep getting closer and closer and closer to see the overall trend of what the y values are doing. All right, the next one, we're going to the x value of -4 from the left. So if I plug in -4.1, I'm at -2.2. When I move over 100th of a value, I'm already down to -20. That's a big jump for a function. And then I go to -200, and then -2,000, -20,000, -200,000. That means that I am shooting down so fast that I have to be going to -infinity. There's no pattern there. And then look at -4 from the right. I'm getting from 1.8 to what is that, 199, almost 200,000 between -3.9 and -3.999. So that means I'm going to positive infinity. I'm going to really, really big numbers really, really quick. So we said that our left and right-handed limits can be infinities, but our general limit cannot. Okay, and these also could be D and E's on Delta Math as well. But our general limit definitely does not exist. A sketch of this graph might look something like this. At x is -4. Oh, I went the wrong way. Hold on. As I'm going from the left, I should be going to infinity. But the right should be going up. I'm sorry. Got some summer brain going on. Oop. Sorry, that's not going to be very pretty. It's going to go something like that. It doesn't matter what the other end of it's doing, but see how one end's going down and one end's up going up, so the limit doesn't exist. But what's weird is when you plug in -4, there is actually a point down here at -5. So I guess there's not technically an asymptote because there is a value there. All right, and then why don't you go ahead and try the last one. The left-handed limit is not going to exist because we're going from -7, then we come up to -0.5, then we go back down to -7.7. We end up being at -1.4-ish. That does not exist. That's going to be this oscillating behavior where it goes back and forth so fast that there's no value it's actually approaching. And then from the right, it's pretty simple. It's 3.5. So this is my graph, just a sketch to help you understand what's happening. Our general limit obviously doesn't exist, and then our value at 1 is 2, so there's some kind of closed point there.